This week we are covering classes and objects. So this is your introduction to object-oriented programming. So basically all a class does is it describes what data you're going to store, and those are the fields that are at the top of the class. And then it also controls how that data is manipulated. It controls what other classes have access to the data by using something called access modifiers. And we've used them for a while now, uh, but there are access modifiers that hide those field members from other classes, and there are access modifiers that make them visible. In order to use a class, you have to create a class object, and that is done by instantiating the class. So when you create the class object using the new keyword, you are instantiating the class. And what we're going to be looking at today are the fields in a class, which are called class members. We are also going to be looking at constructors, which are used to initialize those fields. So basically, you're going to set them to valid values. And then we're also going to be looking at methods. When you create the class, you use an access modifier followed by class and the class name. If you don't include an access modifier, then the default is private. The default is always private. If you want other people to be able to access your class, then you do want to make it public. Okay, so most of the time you're going to see a public modifier here. And then it's standard practice below the class to create the fields. And again, if you don't include an access modifier, the default is private. So you've got the access modifier if you want it to be public. You've got the data type and then whatever you're going to name it. Now, we are pretty much focusing on private and public access modifiers. As you learn more about object-oriented programming, you will learn that there is another access modifier called protected that you can also use, but we're not going to get into that quite yet. After you create your fields, then you have the methods. And the methods also have access modifiers. So by default, they're private, but if you want the methods outside of your class to have access, you need to make them public. And these are set up like the methods that we have talked about before, where you've got a return data type, you've got a name, and then you have a parameter list. If you don't have any data that's returning, then you put in void for the return data type. Okay, so that's pretty much the same as we have been doing. So we're going to take a little deeper look into what we just discussed and look at some examples. So to add fields to a class, as I said, the default is private. However, I think it's good to actually use the keywords. Then you're not letting it default to anything. You're being more purposeful. If you have private fields, the convention is to begin the name with an underscore. Okay, and then you'll notice that we capitalize the first letter of each word. Okay, that is standard practice. Now, if you use private, the only methods that can access these fields are the ones that are inside this class. Okay, you cannot access them from a main method or any other method unless it is within this class. Creating methods. So obviously, if you have private uh, fields, you are going to have to create methods that will retrieve the data and it will put the data into the field because the only thing that has access to those fields are the methods that you create. So for private fields, we create something called get methods and set methods. So typically the way that you would format these is if it's a get method, you are retrieving the data. Okay, and you set it to public, which means that any method, including the main method, can use, get ID to retrieve the ID that is being stored. Okay, and you can see how this really protects your data. Okay, because no one outside of the class has access to it. The only way that they have access to it is to use a method that is part of the class. So the class has total control over what happens to the data in these fields. So we've got get ID, that'll retrieve the ID. We've got something called get full name that actually is returning the first name, a space, and the last name. And then we've got a couple of set methods. So the sole purpose of the set method is to put data into the field. So the return type is going to be void, and you're going to pass it the data that you want to put in the field. And then it's a straight assignment statement. So when you're dealing with private fields, you are going to have get and set methods. And those methods need to be public so that you can call them from a main method or from other methods that are outside of your class. Another very important method when dealing with classes is a constructor. If you don't create a constructor, this method is so important that the C# compiler will actually create one for you. It does this behind the scenes. When you create an object of the class, the constructor initializes that object, meaning it puts valid values into the fields. Okay. Otherwise, the fields, they just kind of land on memory. And if you don't put a valid value in there, it's just going to take on whatever value was in memory at the time, which probably is not going to be a valid value. Okay, so constructors are very important. If you don't create one, the C# compiler will do that automatic. And by default, what it does is anything that is a number, it initializes to 0. And for anything else, objects or strings, it initializes it to null. Okay. So instead of allowing the C# compiler to do this, you can create your own. And there are a couple different types of constructors that developers will create. They will create their own default constructor where they are placing numbers into the numeric fields, and usually you'd put blanks into your strings. You may set an object to null. Okay, so but you're controlling those values. The other type of constructor is one that accepts parameters. So in your main method, you may have asked the user, hey, what do you want for the ID, first name and last name? And you stored those values in variables. And then when you create the object, you pass that data to the constructor, and it uses that to initialize the fields when it creates the object. Okay, so couple important concepts that you need to know if you are creating a constructor. The name has to be the same as the class name. The constructor does not really have an access modifier typically, but it can be public, private, or protected. It's automatically used when you're creating the data, at least the default one is. So if you create one with a parameter, you may want to make that public. The constructor cannot return any value. Its sole purpose is to initialize the fields that are in your class. So because the constructor cannot return a value, it does not have a return type. And you can have multiple constructors with the same name. And obviously, the default and the one with parameters have to have the class name. Okay, so the class name is going to be duplicated here. So how does C# know which one to use? It looks at the method signature, which is the list of parameters that are being passed. So it knows that if you're not passing any, then you go through the default constructor. If you are passing data, then it looks at those parameters and it goes through the parameterized constructor. So here is a little coding example. And you can see here is my club constructor. I have no return data type because that's not allowed with a constructor. And I'm not passing any data into it, which means it is a default constructor. And so you can see I've initialized to zeros and blanks. Then I have a constructor that is receiving data. Okay, so this is a parameterized constructor, and this data is being passed when the object is created, and I'm using this data to initialize the fields. And then below the constructors, that is where I have the get and the set methods that we looked at earlier. Now, once you've created a class, you can actually start using it. And the class itself is a template. It's really not taking up any space in memory, the way declaring a variable does. The only way that you're actually going to grab memory is by instantiating the class, which creates the class object. It is the object that takes up the space in memory. Last week, we talked about value and reference types and how the reference types go into the heap, which is a part of memory that retains its value for the duration of the program. Class objects are reference types, and they are stored in the heap. So to instantiate, all you do is you take the class name, you give your object a name, you set that equal to new, and then you've got the class name again. Okay, this new followed by the class name is what creates the object. Okay, and so when the object is created, it automatically goes to a constructor. This one is going to go to the default constructor because I'm not passing it any data. If I did something like this, okay, where I'm creating a club object called member10, and I set that equal to new club, and I pass it data, okay, it's still going to create the member10 object, but now it's just going to use a different constructor to initialize it. It's going to use the constructor that accepts the parameters. So both of these examples create objects. Okay, both of them are instantiating our class. Okay, they're just using different constructors to initialize the fields. So once you have a class object, you can access the fields themselves if the fields are public, and you can access the methods in the class if the methods are public. You can't really access anything that's private if your method that you're coding is outside of the class. Okay, so assuming that we have access to use a method, you would say you would have your object name dot and then the method name. And then in parentheses, you'd either have it, nothing, or if it's expecting data, you would pass it the data. For fields, assuming that they are public, you would use the object name dot followed by the field name. So I've got another example, and this is the club example. So in the club example, our fields are private. So we cannot directly access those fields. We have to use the get and the set methods. So here we're passing data to club, and then we're retrieving the data using the get ID and get full name methods. And here we're creating a second object, club object, and we're using the object dot set methods, set ID, set first, set last, to place data into those fields. Okay, and then we are using the get methods to retrieve the data and print it. And then we've got another little example here. And this is kind of a full example of club. So you can see I've got the class defined with all of its methods. And then below that, I have a class called program. That's where main is located. And that's where I'm actually creating or instantiating the club objects. So the example we just looked at was utilizing the private fields. And now we're going to take a look at a class. It's kind of the same class, but instead of using the private access modifier for our fields, we're going to use the public access modifier. So using public is not very secure, okay, because pretty much anybody has access to your fields. So that, unless there's a reason to give them access, it's probably not best practice, but you should understand the difference between private and public when it comes to the fields within your class. So we have our club class, and now instead of private, we are dealing with public. Okay, so we don't have the underscore in front of the names anymore. But you'll notice that the constructors look very similar, right? One is called club, the other one's called club. The difference is the parameters. One is initializing to blanks and zeros, and the other one is initializing to the data that got passed. You'll notice that I removed most of the get and the set methods because we don't need them. Because if you have public fields, any method can access them. I did keep the get full name method just because it's convenient to have it combined first and last name. Then if you look in the main method, you can see that creating the object is kind of the same as what I did with the private object or the private fields. Retrieving the data is different because now I can just use my object, a dot, and then the field name. Okay? I don't have to use a get method for this. And then for the second example, where I'm creating a object using the default constructor, and I want to place data into the different fields, I do not have to use the set methods. I can just use the object, a dot, and then the field. And I can set that equal to the values that I want to use. Okay, so that's kind of the difference between private fields and public. This next example is actually kind of fun if you guys want to run it. Um, I have to, I have to entertain myself when I'm doing these examples. And so this one is on mythical creatures. And so you'll notice that I included public and private fields. So the public fields I did were ID, name, and type. But then the private fields are, well, are they dangerous? Are they human? And what are their powers? Okay, so I made all of those private. And so the constructors don't look much different, except for they are longer now because I got more fields. So I've got the default one, and then I've got the parameterized one. And you'll see, because I don't think we've looked at a list in a class. So you, in your constructor, it's basically the same as, creating a new list. So we've got list underscore power, which tells C# about the list, but then it's actually in the constructor that we are creating it because we're using new list in here. Okay, and then when we use the parameterized constructor, it's actually passing us a list. So we're taking that list that we got passed and we're putting it into our private field powers. Okay, and then we've got our get methods for the private fields. So get dangerous, get human status, get powers. And then we've got our set methods for those private fields. where we are receiving data that is passed, and we're taking that data, setting it equal to, our private field. And then you'll notice for set powers, we're taking in a list. Okay, so this is a little bit more interactive than the other examples because I am asking how many creatures you want to enter. We're bringing in that number. We got to keep track of the creatures that we've entered. So we have a creature count. And then you'll notice that we create a creature object called my creature. Now, the ID, the name, and the type are all public. So we can directly fill those in. So for the ID, I'm just using the creature counter. So whatever creature number I'm on, that becomes the ID. Then for the type, I am prompting the user, and because the type is a string, we can read that in from the console and directly store it using the myCreatureObject.type because type is a public field. And then we do the same thing for name, right? Enter the name of the creature and we directly store that. And then we have to handle our private fields. Okay, so is the creature dangerous? Yes. Y for yes and for no. And so you'll notice that I create a variable called temp danger where I read that character, yes or no, in, and then I check it. So basically, I don't really care if they key in something that's not a Y, I don't care. If they key in a Y, then it means it's dangerous. So I'm checking for a lowercase and an uppercase Y. And then if that is true, I am passing the keyword true to the set danger status method. Okay? And then I do kind of the same thing for human. If they key in a yes, a Y, then I send true to set human status. The powers are a little bit more involved because it's a list. So you need to find out if the creature has powers. And so it's a yes or no. You store that in a character, and we're only really concerned if it's a yes. So we're checking for a Y. And so if it is yes, we are creating a new list called POW. And then I'm initializing power entered, which is what I'm going to be storing their power in. Initializing that to blank. And then I get into a while loop where I'm checking power entered. So it says power entered doesn't equal quit. Well, at this point, no, it does not because it's a blank. So enter their power or quit to end, reading that in. If they enter quit, then I continue at the top of the loop where it's checking to see if they entered quit. If they did not enter quit, then I am using the POW object to call that list add method, and I'm adding the power entered. So we go back up here. No, they did not enter quit. Enter their power or quit. We read it in. As long as they don't enter the word quit, we are going to continue adding those powers. And then when they finally do enter quit, we continue at the top of the loop where it checks to see if it's quit. Okay, and if it is quit, we come down here and we add one to the creature counter. Okay, so that's pretty much what the program is doing. It is kind of fun to run if you guys want to play with that. Okay, and here's a little sample run. And the exercises, the Code Easy exercises that you guys did today, did have you include an object from another class within your class. So this is called containment. It's kind of an alternate to inheritance, or some view it as a type of inheritance, um, because you're basically pulling in the data from another class, and you're able to reuse that class information. So this is set up similar to, what we talked about before, where you can have, you know, private and public access modifiers. In the class that you want to pull in and create the object from, that one should have public modifiers. Okay, and then in yours, they can be private or public. To pull in the class, you need to use the class name and an object name. Okay, you don't use equal, new class name yet, because that actually creates the object, and your fields are just telling C# about it. We're telling C#, hey, we got a class, but we don't want it to grab any memory yet. Okay, then we've got our constructors. And if you have a constructor that receives past data, you are going to need the data for everything. So all your private fields, and if you pull in a class object from another class, you need to include all of those fields as well. So for the object, you've got the object name equals new class name, and then you initialize those fields that are in that original class. And then you initialize the fields that are in your new class. So this definitely needs an example, because it's hard to visualize how this works. So we've got a class called club, and I've kept the fields public. So we've got ID, first name, last name. And not a whole lot going on in this club. I've pretty much stripped it of everything except for the constructor. And then we have another class, and it's called Game Club. And so what we do is we create a member object. It's a club member object, which is going to then include ID, first name, and last name. That's all going to be part of member. And then we add to that a string called specialty, and then a numeric field called dues. So our constructor then, the default constructor for our member object, we actually need to instantiate it. So we need to have it grab memory. So we're going to say member equals new club. So what is it going to do here? It's going to run through the constructor. Okay, and then we initialize specialty and dues. So what if I have a parameterized constructor? Well, I can still do member equal new club, okay? And now I just set the values equal to the data that got passed. And I do that the same for specialty and dues. In my main method, if I create a game club object and I decide to use the constructor that accepts parameters, then I'm going to send it the ID, which is from the original club class, the first name and last name, which are all from that original class, plus the new data, which is my specialty and my dues. Now, how do I, write this stuff out? because I've made everything public. Okay? Everything in Club is public, everything in Game Club is public. It makes it actually kind of easy because all I do is I take the object, dot, and then the field. And that works for everything that's in Game Club. But to access the data that is in the original club, I have to take my Game Club object, which is member 10, dot. Inside Game Club, I created an object called member. So I have to use member 10, which is the Game Club object, dot member, which is my club object, dot ID, because ID is the field in my Game Club. Okay, and that allows me to access the value. And I have to do it that way for first name and last name. So I have to use my new class, which is member 10. I've got to use the object that I included in the new class, which is member, dot, and then I have to do the field that is in that original class. And here's how I would go about creating another member where I don't pass it values to initialize in the constructor. If I want to put a value into ID, I have to use the Game Club object. Dot member is what I called my club object when I created it up here. Okay, and then dot ID is the field. And then I can set it to a value. Why can I do this? Because I made everything public. Okay, so I'm doing the same thing here for first name and for last name. Then when I get to specialty, well, specialty is not part of the club class. It is only part of the game club class. So I don't need member in here. I just use my game club object dot specialty. And I can do the same thing with dues. While we were talking and looking at these different examples, we did hit upon several object-oriented programming concepts. Abstraction is one of them. Abstraction is where you're hiding the internal details of the class from the users. And we have been dealing with this from day one. When you guys use console.writeLine, and then you pass it a string. Console.writeLine, writeLine is a method, and we don't exactly know how it's coded, and yet we're using it. And that is what abstraction is. You can actually use methods without knowing how they're coded. Okay, and we utilize abstraction in our daily life, right? We start cars without knowing exactly how the engine works. Now, I know some of you guys might know how an engine works, but I don't. Okay, so it's a lot of us that do not know that. So that is an example of abstraction. We cook using a microwave, and we don't know how that microwave actually heats our food. Now, some of you may know that. I do not. Okay. Data hiding. When we make our fields private, they are hidden. Okay. The only way you can access those fields is through set and get methods. For all intents and purposes, they are hidden. Encapsulation is related to data hiding. So data hiding, the focus is security, right? If you aren't letting people have direct access to those fields, it does make them more secure. Encapsulation is related to both abstraction and data hiding. The focus for encapsulation is on hiding how complex your program is by using, private and public access modifiers. You can totally control what the user has access to, because if you make something private, they cannot use it. Okay, so you make things public that you want the user to know about. Okay, encapsulation basically allows people to view your objects as a single unit. So we know if we create a class that the object is a bunch of fields, not just one, and it has access to all sorts of different methods, okay? But that is hidden as part of encapsulation because we can't, if the fields are private, we can't access them. And all we can really do is use our object, dot, and a method to retrieve or set values. Okay, and that is why the object is sometimes viewed as a single unit. Polymorphism. So we saw this with constructors this week. This is very common in object-oriented languages, not just C#, where you use the same method name for multiple methods. And so what the compiler does, it differentiates the method based on the signature, which is the list of parameters. So those signatures have to be different, and then it considers them to be different methods. And so what this allows you to do is create a whole library of methods. Okay, and no matter what you pass, in this case, find max, okay, whether it's an integer, double, or long, it'll be able to handle it. Okay, so this is just your little introduction to polymorphism, but it is something that is widely used in object-oriented programming. Okay, so hopefully this helps you understand everything better. If you guys have any questions at all, please ask, because this is kind of your foundation moving forward into the object-oriented world, which is actually pretty awesome and cool.